So 4.1a, we're going to review trig ratios, okay, which is SOHCAHTOA, the sine law and the cosine law. Okay, so we're going to recall trigonometric ratios of acute angles. Okay, this is specifically going to be right angles. Okay, we use SOHCAHTOA, and what we do is whatever angle we're talking about, we need to label the opposite and the adjacent relative to that angle. Okay, so this angle so if we had angle X, whatever side we can put an arrow through, I call kind of like this the arrow method. Here we go. Okay, so whatever side we can put an arrow through, that's going to be the opposite side. Okay, if you think about the word adjacent, if you think about that in English class, it kind of means beside. So like if you're talking about like the parking lot adjacent to the school, it'd be like the parking lot right beside the school, right? So the opposite and the adjacent are beside each other. They meet at the 90 degrees. And the hypotenuse, no matter what, is opposite the 90 degrees. Again, opposite, you can put an arrow through it. So hypotenuse, opposite 90 degrees. So for primary trig ratios, what we're doing is we're using either sine, cos, or tan. And sine, cos, and tan have to be beside an angle, okay? So if you look down here, it says sine theta, cos theta, tan theta. So this is where we put the angle. And then we would slot in opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. We're always going to get two pieces of information. Okay, two pieces of info. And based on what we want, we have to choose whether we're going to use sine, cosine, or tangent. Okay, and here's the note. The opposite and adjacent sides depend on the angle being used. Okay, you need to find the opposite and adjacent relative to the angle used. So, for example, if this angle, y, is being used, this will not be the adjacent anymore. It would be the opposite. This will no longer be the opposite. It would be the adjacent. So you really have to label the angle. Okay, example 1, state the 3 primary trig ratios for angle X. So in regards to angle X, relative to angle X, I'm going to use the arrow method to label the opposite. The opposite and the adjacent meet at 90 degrees, and the hypotenuse, which is always the longest side in a right angle triangle, it's always also opposite the 90 degrees angle. So we have opposite, adjacent, and hypotenuse. Now, when it just says to state the 3 primary trig ratios, all it means is state sine x, cos x, and tan x. Okay, so there are 2 parts of a trig ratio. There is the angle part, which is on this side, and then the ratio. So when we think of the word ratio, we think of like fraction. So this part here that we're going to fill in is going to be the ratio. So SOHCAHTOA. Sine is going to be opposite over hypotenuse. So the opposite side is 4, hypotenuse is 5. Cos is going to be adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. And tan is going to be opposite over adjacent, which is going to be 4 over 3. So when asked just to state the 3 primary trig ratios, we're looking for this part of it, the actual fraction part. Those are the 3 primary trig ratios. Okay, example 2. Right triangle ABC has the longest side of 25 centimeters and an angle of 35 degrees. Okay, solve ABC. So when I think of this, I think of, okay, let's just draw a right angle triangle. And let's just name it ABC. Doesn't even matter, ABC. Okay, the longest side is 25 centimeters. So 25 centimeters is going to be the hypotenuse. which is the longest side. So let's put an H there. Okay. It has an angle of 35 degrees. So we can put that for A or C, it doesn't matter. Here's our 35 degrees. Okay. So this question is asking us to solve triangle ABC. So solve means find 3 angles and find 3 side lengths. Okay, so we're going to have angle A, angle B, and angle C. We also have to solve for side A, side B, and side C. So going over notation, angles are always capitals. And side lengths are always lowercase. Okay, so if this is angle A, side A is going to be opposite to angle A. Okay, and we don't know that one. This is hypotenuse. Okay, so let's fill these in. Angle A is going to be 35. Angle B we labeled as like the 90 degrees. And then we have side B because it's going to be the longest, so it's going to be opposite the hypotenuse. So I can solve for angle C by simply doing 180 minus 90 minus 35. So I get 55 degrees. Now, in our triangle, I already started labeling, like I labeled opposite relative to the 35. So I'm going to really label like with green the 35. Okay, and we're going to keep that one. So side A is going to be opposite. That means that side C is going to be adjacent. Okay, hypotenuse never changes. So I have to decide if I'm going to use sine, cos, or tan. Let's solve for the opposite first. So I'm given an angle and I have hypotenuse. In order to solve for opposite, I have to choose the trig ratio that has opposite and hypotenuse in it, which is sine. So we're going to go sine 35. Remember, sine, cos, and tan always have to be beside an angle. Okay, equals opposite, which is A, over hypotenuse, which is 25. Okay, we're going to cross multiply. We get 25 sine 35 equals A. Okay, and just put this into our calculators. I get 14.3. Okay, so let's fill in 14.3. So let's write 14.3 right here. Okay, now we have to find the adjacent side. So I can use trig ratios again, or I can do an easier way, and I can use Pythagorean's theorem. So a squared plus b squared equals c squared. C squared has to be our 25. Okay, it has to be hypotenuse. A and B can switch, it doesn't matter. Okay, and I know that these are not lining up to like the letters that we use to label our triangle, but that's okay. It's okay this time. Okay, so we're going to have 25 squared, which is 625. And then 14.3 squared, which is 204.49. Okay, so 625 minus 204.49, I get 420.51. And we're going to root both sides, right, to get the square off of it. A equals 20.5. Okay, you don't have to take into account the plus minus because we're talking about lengths. We're never going to have a negative length. And these are going to be centimeters. Okay, and that's how we solve an entire triangle. Okay, Sine law and cosine law. So when solving non-right angle triangles, and mostly we use these in acute angle triangles, okay? The sine law and cosine laws are used. So the sine law states like one of these two, and we can just see that they're reciprocals, okay? A over sine A, B over sine B, C over sine C. And sine A over A, sine B over B, sine C over C, okay? So specifically, it's easier to solve ratios or like cross multiplication when the variable, the unknown, is in the numerator. So that's why I provide both of these equations. So it says to find an unknown side length. Well, if you notice, the unknown side lengths are in the numerators, right? So this one's going to be easier. However, if you do use the other one and you only want to memorize one, then that's totally fine. You just have to do a little bit more math, okay? And to find the unknown angle, well, if we take a look up here, okay, angles like sine A, sine B, sine C, the angles are in the numerator, okay? Just to point out again, side lengths are denoted with lowercase abc. Angles are denoted with uppercase, so capital ABC. The sine law is used when you have a complete ratio. So I personally call it like a matchup. So if you have A and the angle of A, like side length A and angle A, you have a complete matchup. You have a complete ratio. Then all you need is one other piece of information, either a side or another angle. Okay, so formally, this is used when two sides and an angle that's opposite to one of those sides is given, so a matchup, or two angles and a side, okay? Because with two angles, you can always find the third angle. So no matter what, you're going to have a matchup, okay? Now, cosine law, okay? A little bit different. The cosine law, we have, again, I give you two different formula. But I generally use the first formula here, like one of these, and I just rearrange. If your algebra skills are not, like you're not as confident in them, then I would maybe memorize both equations. Okay, so to solve an unknown side length, we can see that the side length, like, well, a squared, we'll eventually have to root it, but a squared is isolated already here, and we know that the angle is already isolated here. Okay, just want to point this out, and I'll just point it out on the first two here. I rearranged for ABC. This is important because whatever angle or whatever side length we're trying to solve for, we have to have that angle. We have to have the other two side lengths and that angle. So what that's going to look like is we have two side lengths and the contained angle. Okay, so two side lengths and contained angle. Okay, that's when we use it. For solving for an angle, we need all three side lengths. Okay, and how that's going to look is we're going to have some triangle and we're going to have all three side lengths. Okay, just going back up here visually, what sine law looks like when we use it, we're going to have a matchup. So we're going to have some angle on the opposite side and then any other piece of information. Okay, example 3, triangle RST. We have an angle, we have another angle, and we have a side length. Okay, angle S, angle T, and then side length R. Find the length of side T to the nearest centimeter. Okay, so I'm going to just draw RST, and I draw everyone, they all look like equilaterals, even though they're not, but they're all going to look the same. RST, okay, angle S is 40, angle T is 21, notice the uppercase, okay, lowercase r is 46, so lowercase is going to be a side length, also centimeters gives it away as well, side length. Degrees gives away that it's an angle. Okay, so here's our debate. Okay, so for the sine law, just at the side of the paper, we need a matchup plus one other piece of info. Okay, and at the side of your paper, I'm just going to write cosine. So for the cosine law, we either need all three side lengths or two side lengths and the contained angle. So do we have all three side lengths? No. Do we have two side lengths? No. Okay, so it's implying that we have to use sine law, but we don't have a matchup yet. However, we can get angle R. And we can just do 180 minus 40 minus 21. And I get 119. 119 is not acute, that's okay. It's still gonna work. Okay, so now R and side R, like angle R, side R, we have a complete matchup. So this is gonna be our ratio that we use. So we're finding side length T. So let's put the side lengths on the top. So numerator. Okay, so let's go R over sine R equals T over sine T. So here's our complete matchup. Side R is 46 over sine 119. And we don't have T, so we'll just leave it as T. And then sine T is 21 degrees. Okay, remember sine, cos, and tan are always beside this angle. So these are angles. Do not put the side length beside sine, cos, and tan. Okay, so let's actually just solve this one. 46 divided by sine 119, just so that you guys see what it looks like, okay? So this is essentially like 52.59428. Okay, keep going. And this equals T over sine 21. What we want to do with the sine 21 is cross multiply it up. Okay, so we can bring it up. So we just multiply this number 52 with all these decimals by sine 21, and we get 18.8. Okay, therefore T equals 18.8 centimeters. Okay, so I brought this up before, but formally, to solve a triangle, you must solve for all three angles, all three side lengths. Okay, so example 4, we have triangle ABC. Okay, remember every triangle I draw, and I always need a visual. Like I can't do these questions without a visual. I just draw it. It's always going to look equilateral, but it's not. Okay, side A is 9.6. So remember, capital A is angle, which would be here. Side A is going to be across. So 9.6. B is going to be 20.6, right? Across from B, lowercase b. And lowercase c is going to be 14.7. Okay, solve the triangle. So again, sine, do we have a matchup? Well, no, we have no angles, okay? Cosine law, do we have two side lengths and the contained angle? Or do we have three side lengths? Oh, we have three side lengths. Happy face. Okay, so we're going to use cosine law, and we're actually solving for an angle. Okay, so let's just choose any angle. Let's just do angle A, just for simplicity. Angle A first. So our equation is going to be cos A equals, and specifically, we have to have this A in the front. A squared minus B squared minus C squared all over negative 2BC. Okay, so what we're going to do is bring down the cos A, because the A is what we're solving for. Now we're going to sub in side A is 9.6. Okay, minus side B is 20.6. And side C is 14.7. Okay, and all of these are squared. And we're going to have a denominator of negative 2 times, okay, it's going to be BC. So it's going to be these last two numbers here, 20.6 times 14.7. Okay, so I'll do these separately just so that you can see what they come to. So 9.6 minus 20.6, sorry, squared, minus 14.7 squared. Okay, I get a numerator of negative 548.29. Now, negative 2 times 20.6 times 14.7, I get a denominator of negative 605.64. Okay, let's actually solve for this, this fraction here. So negative 548.29 divided by negative 605.64. We get 0.905306782. I wrote all these down because I'm just going to leave it in my calculator. But what we do is, like, we're actually not solving for cos A, we're only solving for A. So in order to take the cos off of this function, like off of this equation, we actually need to cos inverse. And now that we've learned what the inverse is, we know that when we could cos something and then cos inverse, and it would cancel out what we did to that number. So cos and cos inverse will cancel out, but what you do to the left-hand side, you have to do to the right-hand side. So we have to cos inverse this. Okay, so we're going to get angle A equals 25 degrees. Okay, so now that we have angle A, let's solve, we'll come in here, let's solve for angle B. Okay, so we're going to have cos B. This time, because we're solving for B, we need B as the first side length. And then we're going to subtract the other two. So b squared minus a squared minus c squared, okay, over negative 2, and then it's going to be like the subsequent to ac, okay? So again, we're going to have cos b equals, let's sub in b, 20.6 squared minus a is 9.6 squared, and c is 14.7 squared, all over negative 2, 9.6, 14.7. Okay, and I will put these in my calculator separately. So 20.6 squared minus 9.6 squared minus 14.7 squared. Okay, so for the numerator, I get 116.11. And then I get negative 2 times 9.6 times 14.7. And I get negative 282.24. Okay, this is what I get for cos B. Again, that's not what I get for B, it's for cos B. Okay, so let's write this as a decimal, 116.11 divided by negative 282.24. I get negative 0.411387, and so on. Okay. Now, in order to get the cos off the b, because all I want is b equals some number, we're going to cos inverse both sides. So cos and cos inverse cancel out, and we're going to cos inverse the other side, and I get 114 degrees. Okay, so I get angle A, angle B, and now angle C is just going to be the 180 minus 25 minus 114, and I get 41 degrees. Okay, example 5, given the following diagram, find the length of CD. Round all calculations to one decimal. So CD is this length right here. Okay. So taking a look at like whether or not we use sine law or cosine law. So remember, sine law, we need a matchup plus one other piece of information. Okay, for cosine law, there's two different situations that we use. We use cosine law if we have two side lengths and the contained angle, or all three side lengths. Okay, so in the triangle up here, CDE, we don't have any side lengths, so we don't use cosine law. And then in that case, we can't use sine law because again, there's no matchup if we don't have a side length. So let's ignore this triangle CDE and let's focus on the other triangle EFD. So what happens a lot of time in mathematics is we need to find more pieces of information from say, like, let's call this like triangle 2. Okay, triangle 1, triangle 2. So we need more pieces of information from triangle 2 that maybe help us solve for triangle 1. Okay, in this case, both of these triangles share this line right here, this segment, ED. Let's just call it X. And since both of them share it, let's try to use EFD to solve for X, and then we'll use X to solve more information about the triangle 1. Okay, so looking at EFD, we can see that we have two side lengths and the contained angle. So if we were to just like zoom in on this, we would be 92.4, 2.5, and 3.9. Okay, feel free to redraw just part of like the diagram. Okay, so what we're going to do is we're going to use cosine law. And I'm going to still call this X. Okay, so we have X squared equals E squared plus D squared minus 2ED cos, and it would usually be cos X, but we're going to use capital F. Okay, so E is 3.9 squared, D is 2.5 squared, okay, minus 2, 3.9, 2.5, cos 92.4. Okay, this line right here, I can put the entire thing in my calculator. So 3.9 squared plus 2.5 squared minus 2 times 3.9 times 2.5 cos 92.4. And I get 22.27. Okay, but I'm not done because I'm not looking for X squared. I'm just looking for X. So we want to root both sides, and I get 4.7 meters. Okay, so this X in here is 4.7. Now, let's take a look again at CDE. We don't have a matchup and we can't use cosine, but we do have two angles. So let's find angle C. Let's do 180 minus 56.7 minus 48.2. Okay, 75.1 degrees. So that's going to be in here, 75.1 degrees. Now what we're looking at is, if you want to redraw it, we have 75.1 and 4.7. Well, that's a matchup. Okay, we have C and C. Okay, and what we're trying to find essentially is CD, which is side E. So what we can do now is we can set this up as a sine law. So we're looking for the side length, so let's put the side lengths on the top. Okay, E over sine E equals C over sine C. Okay, so we don't know E, but we know sine E, which is 56.7. And then we know side C, which is 4.7 over sine 75.1. Okay, let's just cross multiply this and let's have this exact. So E is going to equal 4.7 sine 56.7 over sine 75.1. And I can put this whole thing into my calculator. And I get 4.1 meters. Okay, so therefore CD, which is of course also E, is 4.1 meters.